Alright, so this math counts preparation lesson is going to be all about angle chasing and angles in a polygon and polygons in general. So let's get started. Our first geometry video. So we're going to start about our discussion of geometry with angles. Arguably the most important part, one of the most important parts of geometry is the angles. So let's get into the different types of angles. First off, we have vertical angles, which are the most simple type you will see. And vertical angles are basically angles like this. Over here, vertical angles are basically opposite angles over here. And vertical angles are always equal. So if this is x, the measure of this is x, the measure of this is also x. In math counts, you might see some problems in which knowing your vertical angles would be useful. Now we have complementary angles. For those of you who already know this basic stuff, it is going to be a review for you. But I recommend you watch the entire video since I am going to be talking about angle chasing tips. So, complementary angles. The angles sum to 90 degrees. So if we have something like this, and we have a line, let's say we have a line that goes through here, right? A ray that starts this point right here. If this is, let's say this is a bisector, let's say this is 45, well then these two have to add up to 90 degrees since it's cutting a 90 degree angle, so these are complementary. This also has to be 45 degrees. Now supplementary, the sum of the angles is 180 degrees. Now, assuming this angle is right, this angle combined with this angle, these build a straight line. These build this 180 degree angle. This has to be a right angle. So those are 3 examples of angles you're going to see. Now let's talk about polygons. Right, polygons are basically enclosed figures where all the lines are straight, alright? So, essentially a circle is not a polygon, but something like a square would be considered a polygon. A square is a polygon, but a circle is not a polygon. But a square is a polygon. This circle is not a polygon, but the square inside is a polygon. So that's the actual definition of a polygon. Now, we don't really care about classifying polygons and stuff. In math counts, you're not going to be asked to classify them. You're going to ask to find angles and side lengths. So let's get into the angles. Angles in a polygon is pretty simple. To find the sum of the angles in a polygon, we use the formula n minus 2 multiplied by 180 degrees. So basically what this formula is telling us is n is the number of sides. Right, and if n is the number of sides, we subtract off 2 and multiply that by 180 degrees. Now, why is this true? Why are we multiplying it by 180 degrees? Well, if you recall, let's say we have a square. Right, let's say I'm going to use an example to show you why this formula, or how this formula works. So let's say we have a square. I'm just going to assume this is a square, right? Assuming this is a square, not the best drawing. We have a formula n minus 2 multiplied by 180 degrees. In a square, we have 4 sides, right? 4 sides, n is 4. 4 minus 2 is 2. 2 multiplied by 180 gives us 360. And that makes sense, since the sum of the angles in any quadrilateral is 360 degrees. And now, why is this true? Well, try to think, why is this true? We have 180 degrees here. Well, we know that the sum of the angles in some of the angle measures in a triangle is equal to 180 degrees. Now you see where I'm going with this. How many ways can we form a triangle in here? Well, we see that we can build some triangles. We can build a triangle here, and we can build a triangle here, and we're only looking at the angles. We're not looking at how many triangles are formed by this. We see that these two big right angles, the sum is going to be equal to 180 degrees, and essentially the number of triangles we can form, what this formula is telling us. We can form two triangles here, two big triangles. The sum of this is 180, and the sum of this is 180. So when you add them, you get 360, and that's why the sum is 360 degrees. Now we also have a formula for finding each side length, each degree measure of a polygon. But at the end of the day, if you know the degree measure, it's pretty easy just to find each angle. If you know the sum of the angle measures, it's pretty easy to find one of the angle measures, or each angle measure. For example, if this is a square, all four angles are equal, and the sum is 360 degrees, well, 360 divided by 4 angles is equal to 90 degrees. Remember, n is the number of sides? Well, we just divided by n to get our answer. And this is for each angle, remember. This is for each angle, so essentially we have 90 satisfies the equation. Those are angles in a polygon. Now we're going to go on to the angle chasing tips. These are super important because angle chasing is a tough topic for many people, including everyone will find angle chasing difficult at one point. And angle chasing is such a big topic, we're going to have multiple lessons on angle chasing. But here's a basic overview. Whenever you're given a figure, right? Let's say we have a pentagon. Right? Not the best pentagon, right? Or I'm going to draw something a little bit. Let's say we have a regular pentagon. Right? And, alright, so let's just assume the side lengths of this pentagon are all equal. I know it's not the best pentagon. Assuming the sides are all equal, side lengths are all equal, how can we find certain angle measures within this polygon? First, we're going to move on. We're going to start with triangles. A good problem-solving strategy is to break up your figure into triangles. This is because it's easy to find angle measures in the triangle. For example, let's say that this right here is 110 degrees. If this is 110, it makes it a little bit easier to find these angles. Now, obviously, this is not, if this is a regular polygon, this is not 110 degrees, and in fact, 110 degrees is not each angle measure. If you take a look at this, we can use our formula to find the sum of the degrees in a regular pentagon. Pentagon has 5 sides. 5 minus 2 is 3. 180 multiplied by 3 is 540, and then we have 5 angles. 540 divided by 5 is going to be our answer. So we have 540 divided by 5. Do that. Do that. We get 108 degrees. So this is 108 degrees, right? And if we know this is 108 degrees, we know these build a 108 degree angle, and we can even build another triangle like this. These build a 108 degree angle, and it's going to be easier for us to find it. Another tip in angle chasing problems is use bisectors. Bisectors are by far the most useful angle chasing tool I've ever found in angle chasing problems. Bisecting an angle cuts into two pieces, and it can build special right triangles, which we'll talk about in the next video, but it can help you build useful figures. So always remember bisectors. However, today's angle chasing problems are going to be very, considering what we've learned today, it should be a little bit easier for you to catch on. Let's get started with the problems. It turns out the 2019 MathCounts School Sprint had a lot of great geometry problems. So let's get started. This one's more about a logic one, but we'll still go with it. Involves circles. A penny farthing like the one shown. In the original MathCounts competition, you had something like this, which showed like the old bikes. You have some, let's assume this is our bike wheel. We have a big one, then we have a smaller one, right? And when the larger wheel makes 24 revolutions, how many revolutions does the smaller wheel make? The diameters of the two wheels are 54 and 18 inches. So the diameter. Now you might start by thinking, how are we going to do this problem? Could we use, and this is basically just a the trick of this problem is to recognize the geometry doesn't even matter. This is just inverse proportion. We're seeing that when the larger wheel makes 24 revolutions, how many revolutions does the smaller wheel make? If the diameters of the two wheels are 54 inches and 18 inches, the product remains constant. So we can build our thing over here, 18 times x. Now we can evaluate this product over here. We have 54 multiplied by 20. Evaluating the product, we get 1080. Now we have 1080 divided by 18. Just by looking at this, I'm going to guess how we're going to go with this. Well, we know 18 times 5, 90, 18 times 6. So I know we're going to have a 6 over here. And what's 18 times 6? We might want to compute 18 times 6. 8 times 6 is 48. So 18 times 6 goes in perfectly. That means we're going to have a 0 here for the 0. So that means x is equal to 60. And the product remains constant, inverse proportion. So the smaller wheel will make 60 revolutions. If the diameter of the larger wheel, this makes 24 revolutions when in the same amount of time, this is 60 revolutions. And the trick in this problem was, we have diameters, we have circles. You might think, well, can we build radii? No. Can we find the radius? No. That doesn't matter. Here we have inverse proportion. This problem is in some of the last problems because many students who were taking the competition got tricked by this problem. So let's move on. Now we have something more angle chasing style, or more geometry style. We have a regular hexagon ABCDF shown here. The degree measure of angle ABC is x, so we have x over here. And the degree measure of angle AEF, y. What is the value of x plus y? So we're asked to compute x plus y. Now, x plus y, you could try to come up with some way to compute x plus y, but this problem, notice we have a regular hexagon ABCDF, regular hexagon. What does that tell us about the sides? It tells us the sides are all equal. And if the sides are all equal, what are the angles? They're equal. So, we know our formula, we understand our formula, we can use our formula. I say that before you're using a formula, always make sure you know how to use it. So we're going to use our formula 180 degrees. Now we have 6 sides. 6 minus 2 is 4. multiplied by 180 degrees. Now, all we need to do is compute 180 multiplied by 4. We get 720 as the sum of the angles. Now, to find each individual angle, we just have to compute 720. Number of angles is 6. And, well, what do? Well, 6 times 12 is 72. We have a 0, so this is 120. And each angle is 120. This sums to 120 right here. And x is just this angle. So we already have x. X is 120 degrees. We already have x. But now we need y. Y, this builds a 120 degree angle. We have y plus this right angle. We have a 90 degree angle. If this builds the sum of y and 90 has to sum to 120 degrees. And this tells us a valuable tool. This tells us the y is 30. Now we're asked to compute x plus y. 120 plus 30. That gives us 150 degrees. And that is our answer. Now the reason I think why students might have got this wrong is because they might have looked at the triangle. And you're right, there is a triangle built by this, right? We do have a triangle. And this triangle is a little bit misleading in the sense that many students might want to look at this triangle and focus their attention on this triangle, try to find angles here, but they don't notice look at the bigger picture. The bigger picture is hexagon, angles in a hexagon. So whenever you see a regular polygon, find each angle measure in the polygon, right? And then proceed from there. That's a strategy we use in this problem. Remember, look at the bigger picture when it comes to angle chasing. Sometimes, if you're stuck, if you focus on the triangle, you can't find anything, which you won't find anything with the triangle. You need to find this 120 degree measure for each angle. Then look at the bigger picture, find your angle measures, and then proceed from there. So that's our first lesson in geometry for math counts preparation. Hopefully this video is helpful.